Welcome to The Explainer. Today, we're diving into the amazing world of human biology to solve a real-life medical mystery. Right now, deep inside your blood and your brain, your body is playing this microscopic balancing game. It's a delicate dance of water and minerals happening every single second you're alive. But what happens when that balance gets thrown completely off? Well, today, we're going to decode a condition that might sound like a completely foreign language, but it's actually an incredible story about how our bodies work, how doctors play detective, and how fixing a problem way too fast can actually be more dangerous than the problem itself.
Okay, let's dive right into this. We've all been told since we were little kids to drink plenty of water, right? Like it's the golden rule of health. But is it actually possible to have too much of a good thing? Well, believe it or not, drinking an enormous amount of water in a really short time can totally upset a super delicate balance in your blood. See, your blood isn't just plain water. It's this perfectly mixed soup of fluids and vital salts. When you flood your system with too much plain water, you accidentally water down that soup. And that leads us to the star of our medical mystery.
The condition is called hyponatremia. Now, I know that sounds like a massive, intimidating science word, but if we break it down to three really simple pieces, it actually makes perfect sense. Hypo just means low. Na is the scientific symbol for sodium, which is the salt we're talking about here, and emia just means in the blood. So, put it all together, and hyponatremia literally just translates to low salt in the blood. Think of it kind of like a Goldilocks seesaw. On one side you have water, and on the other side you have sodium. For you to feel healthy and normal, that seesaw needs to be perfectly flat, perfectly balanced. Hyponatremia happens when either the salt falls off the seesaw or way too much water jumps on.
So when that seesaw tips, we arrive at our medical crime scene. Like, how does a patient actually feel when their blood gets all watered down? Well, the symptoms start out kind of vague. You might feel a bit sick to your stomach, maybe get a headache, or just feel really confused. But in severe cases, it can lead to deep sleepiness or even incredibly dangerous seizures. But why? Well, it's because of a sponge effect. When the blood is too watery, the cells in your body actually start absorbing that extra water to try and help out. But when the cells in your brain absorb water, they swell up like little sponges. And since your brain is trapped inside your hard skull, it literally has zero room to swell. That built-up pressure is exactly what causes these scary symptoms.
Chapter 1. The detective work. Now, to save the patient's brain from swelling, you'd probably think doctors would just, instantly give them a bunch of salt, right? Well, not so fast. Before doctors can safely fix the problem, they have to figure out exactly why the sodium is low in the first place. They use tools like this clinical flowchart. And now I know it looks like a giant, overwhelming maze of arrows and boxes, but don't panic. It's really just a map. It brilliantly illustrates that while real medicine is super complex, it's completely understandable if we just take it step by step. The doctor is basically playing a giant game of choose-your-own-adventure with the patient's lab results to track down the real culprit.
This whole complex map basically boils down to a really simple three-step assessment. First, the doctors check the blood's concentration, which is just a fancy medical word called osmolality. This tells them if the blood is truly too watery. Second, they check the body's overall water level, looking for clues like swelling in the legs or, on the flip side, extreme dehydration. And third, they check the urine. By measuring exactly how much salt the body is throwing away in the toilet, doctors get these massive clues about whether the kidneys are working properly or if the body's hormones are totally out of whack.
Chapter 2. The Sneaky Sugar Illusion. Because every good mystery has a plot twist, right? Sometimes the blood tests come back and point to a low salt level, but the test is actually lying. In the medical world, doctors have to be on the lookout for fake low sodium. So how does a test fake it? Well, imagine a patient has really high blood sugar, like someone with uncontrolled diabetes. That extra sugar acts like a powerful magnet or a sponge, actively pulling water right out of the body's cells and dumping it straight into the blood. This sudden rush of water dilutes the blood, making the salt levels look artificially low on the lab test. The salt didn't actually go anywhere. It's just swimming in a much bigger pool of water now. So, to find the truth, doctors use a mathematical formula called a corrected sodium calculation to strip away that sugar illusion and see the real salt level. Once they bypass all the illusions and confirm it's true low sodium, doctors organize the suspects into a neat little table based on the body's water level. If the patient is too dry, what doctors call hypovolemic, the suspect is usually something like severe vomiting or diarrhea, where you've physically lost salt and fluid. If the patient's water level looks just right on the outside, or euvolemic, the culprit is often the sneaky hormone mix-up in the brain called SIADH, which basically stops the body from peeing out excess water.
And finally, if the patient is too wet and swollen, hypervolemic, the suspects are usually larger plumbing issues, like a struggling heart or liver.
Chapter 3. The Treatment Game Plan. All right, so we've successfully navigated the maze, we have our diagnosis, and we know exactly who the culprit is. Now it is time to stabilize that wobbly seesaw. What's really interesting here is how the medical guidelines actually split the treatment path entirely based on the patient's symptoms. The very first red box at the top asks one simple question: severe symptoms? If the patient is having a seizure or deep confusion, the path goes left. Doctors must act incredibly fast and aggressively. But if the symptoms are mild, the path goes right, and the entire game plan changes completely. It's basically a high-stakes game of strategy.
Let's look at the specific tools in the doctor's action sequence. For severe, life-threatening symptoms where the brain is swelling dangerously, doctors use a powerful rescue tool: 150 milliliters of 2.7% hypertonic saline infused directly into the vein over 20 minutes. I know that sounds complicated, but it's essentially just a super salty concentrated burst of water designed to quickly pull fluid right out of those swollen brain cells. The immediate goal is just a tiny bump, raising the sodium by just 5 points, which is usually enough to stop the brain from swelling. On the other hand, if the patient has mild symptoms from that hormone mix-up we mentioned earlier, SIADH, the treatment is totally different. No super salty drips here. Instead, doctors just restrict the patient's fluids. They limit them to about 2 or 3 glasses of water a day, just letting the body naturally pee out the imbalance over time.
Chapter 4. The Danger of Speed. Now, you might be wondering, if low salt is bad, why not just pump the patient full of that super salty water until their levels are completely back to normal right away? Well, treating the patient too fast is actually a ticking time bomb. The absolutely crucial point here is this seemingly random pair of numbers, 8 to 10. This is the strict, non-negotiable biological speed limit for the human brain. Medical guidelines state that doctors must never, ever raise a patient's sodium level faster than 10 points in the first 24 hours and no more than 8 points the next day. They literally have to check the blood every few hours to make sure they aren't going over the speed limit. But why?
Because if they break that speed limit, a horrifying consequence occurs. It's called central pontine myelinolysis. Remember how the brain cells acted like sponges and absorbed all that water? Well, they actually got used to it. If a doctor suddenly floods the blood with salt, it acts like a giant vacuum, aggressively sucking all that water back out of the brain way too quickly. When the brain sponge dries out that fast, the protective coating on the brain's nerves, called myelin, literally gets stripped away. Imagine ripping the rubber coating off a live electrical wire. It completely shorts out the system. This kind of severe nerve damage in the brainstem can lead to permanent paralysis or even death.
So, this entire complex medical protocol boils down to one simple truth: balance is absolutely everything. Our biology is incredibly resilient, but it really hates sudden changes. Having too little salt in your blood is undeniably dangerous, but aggressively fixing it without respecting the body's need for time to adapt, that is downright deadly. Doctors aren't just mechanics swapping out car parts. They're careful guides, gently coaxing the body's chemistry back into perfect harmony.
It's just amazing to think that something as simple as salt and water requires such a complex, calculated, and careful approach to keep us alive and healthy. The human body is a miraculous self-adjusting machine, and we are still learning how to perfectly pilot it. So next time you take a nice, cool sip of water, will you think about that invisible, microscopic seesaw silently balancing away inside your brain? Thanks for exploring this crazy medical mystery with us, and always stay curious.